My name is Sandeep Gundlupet Raju. I work for AMD. I'm part of the Yocto team. And I work with great Yocto gurus like Trevor, Mark Hatley, and John Toomey. So we have a great team at AMD for Yocto project. So today I'm gonna give a talk on like getting started with generating a machine configuration tool. So see. All right. So as part of today's agenda, we're going to cover what is the usage of this Gen-Machine-Conf tool, how user can use it, and what would be our next roadmap for the Scarf Gap releases. So the common problem in the FPGA-based hardware designs is like generating the machine configuration files and user configuration files for the Yocto project. All the FPGA hardware-based designs is defined using EDA tools. And for example, in case of AMD FPGA hardware design, all the information is being stored in a file called XSA, and that provides all the hardware configuration, including your custom RTLs, IPs, etc. So in case of a Yocto project build, a static hardware configuration, it's easy to generate the user and the machine configuration file variables, and then you can parse to the Yocto project BSP. However, the most users, they don't end up using the static configuration. They have to have their own custom IP in order to use the FPGA device, all those things. So in that case, like all the users must create their own Yocto project's BSP configuration file. So Yocto project requires a deterministic BSP configuration file that is like, it is defined once and it is being passed at the build time when bitbake is being processed. For all the AMD FPGA customers, requires like software tooling that interacts with the open industry standards like Yocto project, and the tooling that they can incorporate to their like build infrastructure. So what is the solution? The solution is like we need to provide a mechanism to convert an hardware configuration file to a system device tree plus the build artifacts, and provide the user to modify the output of the build artifacts and manually or the automated process. And this tool can be an open source standalone tool to parse the hardware configuration file or the system device tree file to generate the Yocto project machine and the user configurations. And this configuration should allow the user to create their own BSP layers for their custom boards or any evaluation boards. So what is Gen-Machine-Conf tool? So basically this tool enables the customers to generate the build configuration, which can parse the hardware definition or the system device tree to create the custom Yocto project BSP layer for a specific design. And this model can be used for others as well who has a similar requirement for FPGA design, not just for the AMD FPGA devices. Basically, this tool acts as a bridge between the EDA tooling and the Yocto project configuration to automate the BSP creation. Next slide. Right. So once the user has their build configuration, they can easily convert it to an Yocto project BSP layer to help them to manage their work and share with others using the ESDK concept. And also the users are allowed to make like tweaks to the software components using the user configuration. For example, like user wanted to select an different UART configuration for the first stage bootloaders or U-boot or Linux, etc. So basically this tool provides, can be used for both like Yocto project non-SDT builds and the SDT build and the AMD proprietary builds. All right, here is the Gen-Machine-Conf build workflow. So the vendor specific has the EDA tool. The output of the EDA tool can be a system device tree file or then XSA file in case of AMD FPGA. And those file can be input to an Gen-Machine-Conf tool, and that tool will use like a lot of like Tcl scripts, Python scripts, and other like JSON files, and it generates a user configuration and the machine configuration files. Once these machine configuration files are generated, then user can use the normal Yocto project workflows to build and generate any images. Cool. So for the how we're gonna use this Gen-Machine-Conf tool. So we have some README instructions specified in the link here, and user can follow this README instruction. And the first thing is like we have the prerequisites to use Gen-Machine-Conf. First thing, you need to have an XSA file, and next thing is you need to have a tool called XSCT to be installed along with your EDA tools like Vivado or the YPS. So once you have these tools, you can take this Gen-Machine-Conf tool and parse your XSA to generate the machine configuration file. And once it is parsed, then you can use like normal bit-baked commands to build the images for your specific FPGA hardware designs. This is the commands we use for like a custom board or the evaluation board for the using Gen-Machine-Conf. Right, let's see. So once the Gen-Machine-Conf passes the XSA or the system device tree, at the bottom of the terminal in the host, it prints the generated machine configuration file. On all the machine configuration file will be generated under build conf machine directory. So you can run this machine configuration file for like multiple hardware designs, and for each hardware designs, you're gonna generate a specific machine configuration file. And once the machine configuration files are generated, then you can use the BitBake tool to run with the Yocto project and generate all the images. And that's it. And we have a small video here. Right, let me see if I can click on this link. All right, I can make it larger. All right, so I just recorded this terminal session so that you guys can watch. Basically, the first thing is you clone we use the repo tool for all the Yocto project. And basically it clones all the meta layers, and it puts into one directory called sources. And we have a script called like setup SDK, and that basically what it does is it sources the distribution layer, and it will create a template config for that distribution layer. And I just do this because this is gonna take some time. Okay, so once you clone the repo, you can start creating your own branch and check for the status of those branches using the repo tool. And once you set up the branches, you can start sourcing the SDK. Basically, backend it sources the OE net scripts from the Pocky. with Metapeda Linux as the distribution layer. Okay, so here we're gonna use the Gen-Machine-Conf backend. Once you clone the Metaxilinx layer, Gen-Machine-Conf is a submodule, Git submodule of Metaxilinx layer. So it also clones the Metaxilinx layer and Gen-Machine-Conf layer repo, and it will source the environment. So here I'm taking the ZSU 104 XSA as a reference design, and I'm running through the XSCT tool and generating the machine configuration files. I'm gonna forward a little bit this because this is gonna take some time. Okay, so once it is generated, user can use either a kconfig. We have a menu config method, and where the user can have option to select between like two UARTs, set all the BB number of threads, state cache, etc. using the menu config, or by default the menu config is turned on, and user will run into the silent config. And once the machine configuration files are generated, the tool will print what is the machine configuration, machine name, and the distribution image name. Cool. Once the machine files are generated, it will be located under conf machine directory. So ZSU 104 test is the machine configuration file we are generating for the particular XSA, and this is how it looks like. And user are allowed to change any of the configuration, like I want to select an different UART instead of like PS UART or PL UART, such kind of things. Cool. That's it. If you have any questions, I can take up the questions. Oh, I forgot. I have last slide. So what is next in the ScarpGap release? The tool will support the modular approach. And as of today, we are specifying the machine name or the SOC family name and use it for each XSA or the SDT file. And in ScarpGap, we're gonna the tool will detect dynamically based on the XSA or the system device tree file. And in ScarpGap, we are adding the system device tree overlay support. And today, all the generation of the machine configuration file for system device tree flow is based on the script, a standalone shell script, and that is converted to an like Python modules and ScarpGap release. Cool. That's all I have for today.